Hello, welcome once again to the world of quadratic equations. Okay, so in this video, we'll be learning how to solve quadratic equations by completing the square. Okay, so I'll write the topic for you. The thing that we'll learn is how to solve quadratic equation using the method of completion of squares. Okay, so in the previous video, we saw that how to solve quadratic equation using factorization. So this is the second method, and in this method, we are learning the second way of solving quadratic equation by completing the square. So before learning this thing, I want you to know or to get familiar with three important concepts that will help you while solving a quadratic equation using this approach. First, and the important thing is, you know that a plus b whole square is a square plus 2ab plus b square, or a minus b whole square is a square minus 2ab plus b square. All of you know this. This is a one of the very frequently used identities. Okay, so now my question is, we have always focused on going from here to here. Whenever if anyone will ask you what is the formula for a plus b whole square, you will say a square plus 2ab plus b square. What is a minus b whole square? You will say a square minus 2ab plus b square. Simple. But have you ever thought of that if you had this, if in any expression, if you can see this particular pattern of three different terms, you can always write it using this. Or in same case like this, if you see a square minus 2ab plus b square, you can always write it in the form of a minus b whole square. This is an important concept that we'll be using in the method of completion of squares. Okay, we will try to we'll try to write down the given expression, the given quadratic expression. This will try to insert these terms in that, and then combining these three terms, we will write it in this way. This is the first important thing. If it is plus 2ab, it will become a plus b whole square. If it is minus 2ab, it will become a minus b whole square. That we'll see later on. I'll show you a lot of examples. In this concept will be very much clear. But I just wanted you to know this concept. Okay, second important thing is, suppose I have a equation, say for example 2x plus 3y equal to say 0, for example. Okay, so I can always add and subtract the same quantity from this. Okay, it won't make any difference even if it is a not an equation, just an expression. Say 2x plus 9y, I can write this as 2x plus 9y, say plus 3 minus 3, depending on my requirements. It won't make any difference because plus 3 and minus 3 will cancel each other. Okay, similarly if I have this, I can write it as 2x plus 3y, say plus of 99xy minus of 99xy equals to 0. It won't make any difference. Why? Because this plus and minus will cancel each other. Okay, I know this is very obvious things, but I want you to know because these things we'll be using in this method of completion of squares. And third important thing is that suppose I have a quadratic equation ax square plus bx plus c equals to 0, and say the roots are alpha beta. Alpha and beta just a way of denoting the roots. Okay, say I have a quadratic equation ax square plus bx plus c equals to 0, and the roots are alpha and beta. What if I'll multiply this with any constant value? Okay, say I multiply this with the quantity k times ax square plus bx plus c equals to 0. The roots of this equation will not change. Still the roots will be alpha beta. Even if I divide this by some valid quantity, ax square plus bx plus c divided by some constant quantity k equals to 0, still the roots will be alpha and beta only. Always remember that. Doing such things will not alter the roots of the given equation. Okay, even if I take out something common from the equation, for example, let me take out a. So when I'll take out a, it will become x square plus b by ax plus c by a equals to 0. Still the roots of this equation will be alpha and beta only. It will not change. Okay, so now let us see how to solve quadratic equation by completing the square. I'll try to make you understand this concept using some examples. Okay, so let us take one first of all very easy example, that is if I have a quadratic equation, say x square minus 6x plus of 8 equals to 0. Okay, x square minus 6x plus 8 equals to 0. I need to find the roots using the method of completion of squares. Okay, this is the question. Now see what I'll do. I'll try to write this in the form of a square minus 2ab plus b square. Why? Because I know that these three terms combine to form a minus b whole square. Okay, so let us see how we can do that. Now I have x square minus 6x plus 8 equals to 0. This is already a perfect square. I can write this as x whole square, which will resemble the term a square. Okay, minus of 2 into, now this is my a, so I will write my a here, into, I need a b now. Okay, now what will be my b? Now see, I have minus of 6x, minus of 2x is already done. So if I write here 3, I'll get minus 6x. So this is minus of 2 into a into b. So this 3 will be my b, because together it will give me minus 6x, which is in the equation, and this a is x, 2 as it is, b will become 3. So if I'm adding b, now I need a third quantity b square. So I will add 3 square. Okay, and since I'm adding certain quantity to the equation, I need to subtract the same quantity also. So minus of 3 square, and the last term I will write as it is. So this 3 square becomes b square. Okay, so this is my a square minus 2ab plus b square, which is nothing but a minus b whole square. Okay, so this thing finally becomes x minus of 3 whole square minus of 3 square is 9 plus of 8 equals to 0. Okay, so we started with this and I wrote the same equation in this format. Clear? Now this becomes x minus 3 whole square minus 9 plus 8 is minus of 1 is equal to 0. Okay, so this becomes x minus 3 whole square is equal to 1. Okay, now you know that when I'll remove the square root, I'll have two possible values, that is either x minus 3 will be equal to plus of 1 or x minus 3 will be equal to minus of 1. Okay, so from here I'll get the solution x equals to 3 plus of 1. From here I'll have 3 minus of 1. So the roots are x equals to 4 and 2. This is the method of completion of squares and finding the roots of a quadratic equation. So I hope this method is clear now. Anyways, we'll see some more examples so that it is completely clear with all of you. Okay, let us take another scenario in which the equation is 9x square minus 15x plus 6 equals to 0. Okay, so one more thing always try to remember is that whenever you have a coefficient of x square that is not equal to 1. Okay, now I told you even if you divide this equation by anything, the roots will not change. So in that case always try to divide the equation by the coefficient of x square. Okay, in this case I'll divide it by 9. So I have 9x square minus 15x plus 6 whole divided by 9 is equal to 0. So this becomes x square minus of 15 by 9x plus of 6 by 9 equals to 0, which is nothing but x square minus of 5 by 3x plus of 2 by 3 equals to 0. Okay, so the roots of this equation and the roots of this equation will be same. That is what I mean to tell you. Okay, even if you solve this equation directly, then only you'll get the same roots. Okay, and even if you solve this equation, you will get the same roots. But why we are doing this? Because when we'll divide this by 9, this quantity becomes only x square, so I can directly write it as x whole square. Okay, now let us apply the same logic. Now this is x whole square minus of, now I need 2ab, 2, a is my x, now I need b. How will I write b? See, it is 5 by 3, so anyhow I need 5 by 3x. So if I'll write here 5 by 6, okay, so this 2 and this 6 will cancel each other, and this will finally become minus 5 by 3x. Are you getting me? What I'm telling you to tell, what I'm trying to tell you is that this 2 and this 6, which will give me directly minus 5 by 3x as it is. Okay, so that is why I wrote 5 by 6. So this is my a square, this is minus 2 into a into b. The value of b is 5 by 6. Okay, now since I have a b, I need plus b square also for writing it in complete format. So I'll do it that way. I will add 5 by 6 whole square, and since I'm adding quantity, I have to subtract the same quantity from it, and the last term plus 2 by 3 as it is. Okay, so now what do I have? Now this is plus b square and remaining term as it is. So this becomes x minus of 5 by 6 whole square minus of 5 by 6 whole square is 25 by 36 plus of 2 by 3. Is this clear? Equal to 0. Now let us see what do we get after this. So this becomes x minus 5 by 6 whole square. Let us take LCM. 36 minus 25 plus of 24 is equal to 0. So this becomes x minus 5 by 6 whole square is minus of 1 by 36 is equal to 0, which is nothing but equal to x minus 5 by 6 whole square is equal to 1 by 36. Now when I'll remove the square, I'll have two solutions, that is x minus 5 by 6 is either equal to 1 by 6 or x minus 5 by 6 is either equal to minus 1 by 6. Okay, so when I'll solve this first one, I'll get x equals to 5 by 6 plus 1 by 6, which is nothing but equal to 1, and from here x is equal to 5 by 6 minus 1 by 6 is equal to 4 by 6, that is 2 by 3. So the roots are 1 and 2 by 3. I hope the method is getting clear to you. We'll end this question, we'll end this concept with one last example. Okay, this is a basically different type of example that you can expect questions based on that in your exam. Okay, so what it is, let the equation be x square minus of 2 times a plus 2bx plus of 8ab equals to 0. This is my equation and I need to find the roots using method of completion of squares. Again the same logic, completely same logic, nothing different. We'll start with this thing, x square, x whole square minus of 2 is already there. I'll put x that is already there into a plus 2b. This is my b. So now try to relate it this way, a square minus 2 into a into b. Now I need a term b square and this is my b. So I will write plus of a plus 2b whole square. Since I'm adding a quantity, I have to subtract the same quantity, a plus 2b whole square plus of 8ab, the last term, equal to 0. Clear? Okay, so now the equation becomes x minus of a plus 2b whole square minus of a plus 2b whole square plus of 8ab equals to 0. Now let us try to simplify. This becomes x minus of a plus 2b whole square minus of a square minus 4b square minus of 4ab plus of 8ab equals to 0. This is normal simplification. All of you can do it. I'm just doing it for you. I don't think that much explanation is required for this. Finally, I have x minus of a plus 2b whole square is equal to a square plus of 4b square and minus of 4ab. So this becomes x minus of a plus 2b whole square is equal to a minus of 2b whole square. So when I'll solve this, I'll have two solutions. x minus 2 x minus of a plus 2b is either equal to a minus 2b with a positive sign, or x minus of a plus 2b is equal to negative of a minus 2b. From this I'll have x as equal to 2a, and from this x is equal to 4b. Okay, so the two roots are 2a and 4b. Hence, I think now this method is quite clear to you people. You're just okay enough, just good enough now to solve questions related to this concept. Okay, so I hope you liked the video, you understood the concept. Do like the video, share it with your friends, and please subscribe the channel for more concepts and more ideas related to this subject. That's all in this video. Have a nice day. Thank you.